Hello everyone. So happy to be here, and I am Verena. I'm testing out new streaming software today. So I'm going live with StreamYard. So it's a new experience for me. And I just thought I would like to kick off the year. Happy New Year to everyone. I would like to kick off the new year committing to weekly live streams and making these really, hopefully really worthwhile for you to watch and really valuable in terms of the teaching content. And I've put out a schedule, so you can have a look on that, on the topics. They will be further down in the page, just telling you what the different topics are going to be. And today we're going to start talking about the basics, sourcing materials locally and developing high performing mixes as an extension of that. So this is a question we get asked a lot. And in actual fact, when we're teaching this online and when we're going into this into more depth, we're spending about 2 weeks on this topic. So I can only skim over it today. As part of this live, I'm going to show you some slides and talk about different things and hopefully give you a deeper understanding about it. And I'm also going to do a little bit of hands-on, as much as I can do, being behind the computer. So the question about, where to start, where do we find materials, what are we looking for, and how do we know that we can use these materials for the earth building application that we want to do? And there's a lot in there. So really, I think we need to start with a little bit of soil science and then progress into showing some tests and then take it from there. And really what I would like to show with this is that it's twofold. So one of the challenges of earth building is that there is no such thing as a fixed recipe. So you can't just open a book and go, oh yeah, I need 2 parts of this and 1 part of that, and then I'm going to be sweet, because soils vary greatly from place to place. So that's a challenge, but it's actually also what makes earth building really exciting and interesting, diverse, in my opinion. And I think there's a lot of scope in demystifying this a little bit, because once you get the fundamentals of it, and once you really get into this beginner's mind, I guess, a little bit, and into the mindset of testing and being curious about what happens when you use soils, knowing the basics, you will be able to develop your own recipes quite easily. And that's what I'm really intending to convey. So really into testing, like really into developing well-performing soil mixes, and also really into getting to know soils across the globe. And this is one of the beautiful things that come out of the online learning for us, for me personally, is that people come to me with lots of different soils and they ask, what is happening here? How is this performing? What do I have to do with them? And I'm feeling myself really confident, even over video, to give guidance. And at the same time, the soils come to me all across the globe via the internet, and it's just beautiful. I'm very passionate about this. Okay, so I'm going to share my slides for a moment, and just starting off with very basic, where do we find these materials and what are we talking about in the first place? So for earth building, we're talking about subsoils. So you see here a section through a soil profile, and it is a very, perfect one here. So you have the vegetation at the top, and then you have your topsoil, the stuff that grows plants. And below that, there's the subsoil. And this is the layer we are talking about when we're talking about sourcing materials for earth building. So you want to be sure that the topsoil is removed. Ideally, that there's not too much contamination of that. In practice, that is not always 100% possible, and it doesn't matter, but you really want to be able to strip back the topsoil and get to that subsoil layer. And in different places, that is at different depths. So in some places, you will only have a couple of centimeters of topsoil. In other places, there's meters of topsoil. And a really good starting point is to, when you're like in your local area, when you're like getting curious about where do I find subsoils, what kind of subsoils are present, is to start noticing cut banks next to roads, or if there is like a building site and there's cut soil, that you start paying attention to that and seeing, you know, like what are the layers that are present. And these vary greatly, even locally. So it could be, you know, 100 meters over to one side, and this profile could look quite different. And also often, typically in the subsoil itself, there is layers. So there's layers that are rockier, layers that have got finer particles, the way you see over here. So really encouraging you to start opening up your eyes and start noticing where there is earthworks, you know, what kind of material is getting excavated, or if you start seeing banks, even at rivers or on the coast, start paying attention to these cut banks and notice the layers. And really what clay is, like what subsoil, what is happening is that there's always, like, geologically, there's an erosion process happening, and this subsoil originates from the disintegration and transformation of bedrock. So over eons, there is this mechanical erosion that happens through heat, wind, freezing, those kind of processes, and then also chemical transformations and movements of air, so rain, evaporation, and so forth. And the tendency is for particles to become smaller and smaller and smaller, like being broken up into their smaller particles. And then that leads to this subsoil, this whole mix, actually being made up of many different particles of different sizes. So this is an art installation. This is not how you find it in the soil, but I thought I'd put it in there because it shows what I'm talking about. So here, this is an art installation that happened in Zurich in the 90s, and they sieved out the different particle sizes and just layered them to showcase this. And you see that there's big rocks, and then there's gravels, and there's finer rocks, and which we call sands, and then it gets finer and finer and finer. And this is what we're talking about. So it's in real life, it is not, of course, sieved out the way I just showed. In real life, it's all mixed up. And you will always find that subsoils are made up of these different particle sizes, and the different particle sizes have different names. So we have stones, gravel, sands, and then there's a constituent that is very, very fine, that is a silt. And then there's a constituent that is even finer than the silt, looks often very similar to silt, but it is even finer, and that's the clay. So the clay is really the magical ingredient in the subsoil. It's what sticks everything together. And you'll see that it is also sometimes the problematic ingredient, because it tends to swell and shrink when it gets wet and when it dries. So the clay is really what we need to understand, that how it behaves, because it influences how strong the whole mix is for building, and also how much it will shrink. So often the question is, you know, like, people understand this, you know, they understand that the clay is the binder in earth buildings, that the thing that sticks everything together. But then the question is, you know, how many percent clay are present in my soil? You know, how do I know this? And how can I be sure that I have enough clay, or is there too much clay? And how do I know how much clay is in the soil? And again, you know, this being a natural building material, it varies. So even locally, even within the same dig, you will have a variation of percentages of clay. So there's a tendency but the exact percentage of clay is not actually that important. What is important is to understand whether a soil is high in clay or low in clay. And it is also important to understand if you're actually looking at clay or if you're looking at silt. Because silt often disguises itself a little bit. It feels a little bit sticky. It could be mistaken for clay, but it is actually quite dusty and not strong. So you want to be sure that there's not too much silt in your soil. So this is really what you're looking at. And you don't need to take your soil sample to a lab to get this tested, because a lab would give you a very accurate reading, but it would only tell you something about your exact sample, and it might be different, like just a few meters over. So I really want to show you a couple of tests that you can do in the field to give you confidence that you understand what kind of soils you're talking about, you're like encountering, you're dealing with, and then you can take it from there. So the first thing really is like engage your senses. It is very useful to start touching the material and to mix it with water, because that will teach you a lot about the material you're dealing with, and the water sort of activates the clay. So you'll start feeling whether it's sticky, whether it's gritty, slimy, and so forth. So you're the first thing is you're just touching it and getting a feel for stickiness and grittiness type stuff. And then from moving on from there, you're just kneading it, and I'll be doing it and I'll be showing you in a moment. So I just want to give you the theory first before I get muddy hands. And from there, you move on into doing this really simple hand test, which is called a disc test. And basically what you're doing is you're activating your clay with some water, you're kneading it, and the kneading is really important. I'll be talking a little bit more about this afterwards, but you knead it until you get something that is really like plasticine. And then you form a little disc, and you can use a piece of pipe to make the disc. You cast the disc and you let that dry, and that will start really telling you a story about the soil you're dealing with. So once you have this dry disc, you can read a couple of things from it. You can read how much it shrinks. You can see if it's strong. You can try and break it and see if it's strong. And you can rub it and see if it is dusty. And these three things are really important pieces of information. And I'll be showing you how to do the disc test, because I really think this is the most useful test, full stop. Like when you're first encountering a soil, I would just do this. Often you will find in the literature, you find the jar test. And the jar test is not useful in my opinion. The jar test, you put soil sample in water in a test, and you shake it up, and then you let it settle out, and it will settle out in layers. So you will have the bigger particles obviously falling down first and settling off, and then the finer particles settling on top. But you're really interested in the finest particles. So you're interested in your silt and you're interested in your clay. And it is very hard to tell the difference in a jar test between these two constituents. And B, clay swells when it's wet. So it will look like there's more depending on the type of clay. Some clays fell out really slowly. So like that reading is not really useful. You can't just read, there's like 1 centimeter of clay, so I must be having 30% clay in my soil sample. It's not how it works. And in actual fact, if you look at the literature, Professor Minke put out a really seminal book. And he had a testing laboratory in Germany, and he has looked at this jar test, and he has proven that it is up to 1800% out. So that's a really big margin. So we are not using the jar test at all. What we're doing is we're doing this disc test, and that gives us really good indication to start off with. And then just another one before I get into the disc test is the hand wash test, which again, like you're naturally already covered. Your hands are covered in clay when you're doing the disc test, and you're just washing your hands at the end of that process, and you're observing what happens. And the hand wash test is useful to understand whether the sticky material you're encountering is clay or silt. So if when you're washing your hands, the clay just washes off instantly, you have an indication that you have a high silt content, and then I would be careful with it. Like you just have to carry on testing and seeing how the soil performs. So that's a really simple thing. It's just a natural progression of that simple hand test. Just wash your hands and pay attention to what you're encountering there. So I am going to show you for a moment how we're doing the disc test, because I found that when I'm teaching this as part of the Earth Building Academy, as part of my 3-month course, and we're talking about these tests and about sourcing soils for about 2 weeks. Still, I'm trying to, the information I'm giving is more in depth, obviously, than what I'm doing now, but I'm showing it and everything, but still students come back and they have challenges. They go, what do I do next? So just wanted to really show you this, to get rid of a couple of things that could be mistakes. So just wanting to show you for a moment what I'm talking about, when I talk about digging subsoil. So that's our clay that we use for making mud bricks. So you see there's lots of different particles in there, like little gravels and little pieces of clay and so forth. This is the local stuff we have here on our land. This stuff is just down the road. So you see, kind of similar but different. And then just to give you another couple of ideas of how clay could look. This one here is a pure China clay. So it's a very pure clay from the pottery supply shop. And this is just something I found on the side of a river somewhere else. So you see different colors, like different grittiness. And usually you either dig it and it comes out in a sort of a semi-dry or like a little bit puggy, sort of a little bit damp lump, or it is summer and it is dry. And really the first step you should do is, when you test, is that you put it into a container and you just put a little bit of water on it. And ideally you give this overnight, or you give it a couple of hours, because you want the water to penetrate into your soil and start absorbing. So this is called hydration. There's a very big correlation between earth building and cooking. So the material needs enough time to absorb water, and you can speed the process up by working it more and forcing the water into the mix, or you can just let time do a bit of the job, and just let it hydrate overnight. And then typically, you will end up with something that is still lumpy, but it's damp. And this clay is very sticky, so I'm not going to use this because it's going to be unruly when I have to get back to the computer. But just showing you, just by hydrating, it's already quite sticky, but it's also still lumpy. And this is typically where the mistake happens. So, you're thinking this, it's sticky and it's good, like I'm going to make a disc now. But it is really important that you work the soil sample enough before you make the disc. And the reason for that is that when you're hydrating, the water needs to be able to penetrate between your clay particles. And the clay particles are like a stack of cards. It's like discs, and you need to have enough time and motion for that water to really go between these plates, because this is what activates cohesion. And I'll explain this more in a moment. But if you don't work your sample enough, you will also have small dry lumps in it, which distorts the reading. You know, like all of a sudden the clay lump, the small unactivated clay lump will feel like a little piece of gravel. So you're not quite doing your sample justice. And the other thing is that you will not have activated the stickiness of the actual clay enough to bind as much as it could. So your strength reading will be up. So really encouraging you to put, you know, good effort into kneading or mixing to really end up with something that is very smooth and like plasticine. So this is this. So it's the same clay, just with water and motion. And you will also, like when you're making friends or acquaintances with the clay, you will see that certain amounts of water will give you different kinds of consistencies. So that's the states of hydration. If you have too much water in it, it will be too runny and you will not be able to make a disc. If it's too dry, you're working quite hard, and you really want to end up with something that is a little bit like plasticine, you know, like when we were in kindergarten and we were playing with the clay. And I just prepared this earlier because I want to speed things up a little bit. And I'm going to now wet this piece of cut-off pipe. So I made a little mold to make a disc. So I'm going to wet it a little bit so that it releases easier when I form the disc. And then I'm going to put this on an underground, like a surface, so that I can show you on video. So I'm just, you would do this on the table, but I'm showing you, you're putting the your mold down, and you're pushing your clay into the mold. I'm going to show you in a moment. You're pushing it in and smoothing off the top. Like this. So very simple, you know, like you can spend a little bit more making it nice at the top. Doesn't matter so much, you just want it kind of even. And then you just push it out, and wetting the mold is useful because then it sort of slides out easier. And that's what it is. So you're just casting, I'm trying not to get it onto the computer. You're just casting a little disc like that, and you let it dry out in the sun. Or if you are in a hurry, you can speed dry it. You can put it in the oven at low temperature. As long as you don't fire it, as long as you don't cook it at too high a temperature, that's totally fine. So I'm just now washing my hands and also showing you, you know, like I've been rubbing it, and like this is a high clay content soil sample, so it's a little bit hard to get the clay off. So I'm having to work a little bit to get to a place where I can touch the controls on the computer again. But that's all there is to it. And the important thing is that you work the sample enough so that it really is free of lumps. If you have little stones in this sample, I would pick them up. And then just let it dry and see what happens. So these ones are ones that I made earlier, and they're dry. And just showing you, you know, like when you then have the sample, you will see that it shrinks a little bit, and that's the clay amount in the soil. This is what leads to shrinkage, and this is what you need to understand and control in building, because too much shrinkage is hard to deal with. Depends a little bit on the technique. Just showing you another one So both these have a fair amount of shrinkage. Some soils have more shrinkage. If it's a lot more than this, it is a little bit unruly. Some have less, they have only a millimeter here. So this amount of shrinkage to me indicates there's a fair amount of clay in both these samples. And then the other thing you can do is you try and break it. So it's very strong. I probably could break it with a hammer, but I struggle breaking it with my hands. To give you an idea, ones that we did another time with another sample, you see it's broken, and now the smaller ones are harder to break, but they, like you can just snap them. And in actual fact, when you're comparing soils, and this is something I'm really encouraging people to do, compare soils, because then you start building up muscle memory around it, and you can start understanding how the different soils behave, even if they look the same color and so forth. So get different samples, maybe at different depths, and start making these tests and start seeing what happens. You could also make a disc where you don't activate the clay much, like you just sort of knead it together a little bit, and maybe make one with little lumps, and you see that it is going to be weaker. So yeah, like a sample that is really hard to break will indicate a strong clay. And then the third thing that you can do with this sample here is that you start rubbing it, and there's hardly any dust coming off. So that would indicate that it is not very high in silt, because if you have a very silty or very sandy sample, like doing this will just shed. So this is really, it gives you enough information. So you will, if you have very little shrinkage, and when you're rubbing, there's sand coming off, it is a sandy sample. If there's a lot of shrinkage or a fair, medium-sized amount of shrinkage, there's more clay in it. If there's dust, it's silty. So it's just a starting point, really, because the only thing you need to understand, or it is useful to understand, is whether you're dealing with a high clay content subsoil or a low content subsoil, because that will then inform what you're doing next. And I'm just going to carry on with this to show you what we do as a next step. So just circling back to tests for a moment, again, really what we're doing here is we're asking the fundamental initial question is this test, is this soil high in clay or low in clay? And you will find other tests in the literature. So for example, the German literature mentions the Niemeyer test, which is great, like it is very methodical and thorough, but it's actually quite a lot of work to get a reading that also doesn't tell you much more than what we've just done with the disc test. And I've touched on the jar test. And then there's the other one, which is a ribbon test, which basically just involves, instead of making a disc, you're just sort of going like this and seeing if you can make a ribbon. And it's a test that comes out of the wastewater management, I think it's the Australian and New Zealand wastewater management standards, and there's a table. I can link to it in the comments of the live stream. I will do that because it's useful. And it's very a very, very rough and ready test you can do in the field, and it actually gives quite an accurate reading. So that's a good one too. It's not so useful to read, whether it's silty or not. So I really liked the disc test. So as a next thing, just really also wanting to explain a couple of things that the characteristics of subsoil. So I was talking about cohesion. So there's two things that are really important. It's the plasticity and it's the cohesion. And it's fancy words, but really I've touched on both of them already. the plasticity is how much water is in that mix. And you will get a feel for that when you start working with the material. You know, like you put in a little bit and it's kind of dry, and then you put in a little bit more and it turns into something that is like plasticine, and then you put in more water and it will turn into something that is more liquid and doesn't hold shape. So it is a fundamental property of clay, is that it can go into this plastic state that can be modeled without deforming. So potters use this amazing property of clay to do that, to form vessels. And in a way, we're doing a similar thing when we're building. And in earth building, there's lots of different techniques, and different techniques will use soils at different states of hydration. So some will use this clay quite dry, and some will use it quite liquid, and some will use it in the middle. So that's just something to play with and understand, is the water content definitely affects the mix, affects the performance of the mix. And also keep in mind that more water in the mix has to evaporate. So if you have a lot of water in a mix, that water evaporating will leave voids. So it will also lead to more cracking, because that water has to go somewhere. So play with that, really encouraging you to start feeling how the mixes change with different amounts of water. And then the most magical part of all of this is cohesion. So cohesion is the stickiness. And the clay is really what does this. So like when we're adding water to a dry subsoil sample, the water goes into the soil and activates the clay, makes it all sticky, and you can form it, and then it dries out again. The water leaves the sample or the building material, and it keeps its shape, goes hard. So this is really, what earth building is about, like in its purest form. And what we're actually doing in our work is we're not relying on other types of binders. We're only using the clay as a binder, and we're working with this cohesion a lot. So this is why I was working the sample a lot, was because I am activating cohesion. I am working with the plate structure of the clay, and I'm allowing the water to penetrate between the plates, and I'm also encouraging the water to penetrate between plates. So we're soaking overnight or for a little while, let it happen in a passive kind of way, let the clay just absorb, and then we're also actively working the clay to knead the clay particles and align them and put this water between the clay plates. And you see here, this water that goes between the clay plates, this is actually what creates the stickiness and the cohesion. It's an electrical charge between the molecules. And if there's not enough motion, we're missing out on some of that. It really requires a mechanical movement and working of the clay to fully develop that. So often we get asked, can we use a thing like a concrete mixer or something like that to just tumble our mix? And it's not enough often. It's not enough to really activate cohesion, because it will just, the clay sort of just forms blobs, and the water doesn't get forced into the middle of the clay lump. You need, if you're using machinery, you need a machine that forces the mix, so like a pedal mixer or like a rotary hoe or something like that. Or if you're working with your hands, you have to knead. So it's like baking. It's like making dough. And that explains, like the first step when you're doing first encountering the clay, what do I do with this to understand it better? So I've showed you the disc test. The next step is, what do I do with this information? And what do I actually want to achieve with this material? And again, this is a whole, this is, I could write a book on this, because there's lots of different earth building techniques. And obviously, depending on the soil and depending on other materials that you have available locally, and depending on the technique you want to use, the recipes will vary, and you will just have to test your specific scenario. But here I just want to touch on the overarching, like the eagle eyes view of this process. So really, if you think about earth building, in most instances, it is a recipe. So in some cases, you will be using the soil exactly how you dig it and just form your building or your building material with it. It's not very often that this is the case, that you just use it exactly the way it comes out of the soil. Often you will be adding stuff to it, adding aggregates or fibers to it to improve your mix and to create something that is really high performing. And by high performing, I mean, depending on the application, there's not too much shrinkage in it, so you don't end up with cracks. It is strong and it doesn't dust so much. So depending on what you're using it for, depending on what you're doing, if you're building a mud brick building, or if you're using your clay for an earth plaster, or if you're doing an earthen floor or a pizza oven, those requirements will vary a little bit. But you're going into it with the end in mind. So you're thinking, for example, I want to develop a plaster. So you will be starting with plaster samples. The same if you want to make a brick, you will start making brick samples or floor samples, or other things. Not so much for pizza ovens. Pizza ovens are quite a good introductory smaller project, so you don't have to make a miniature pizza oven as a test, but you get the point. And here is, again, like this opens up a whole raft of questions. What kind of aggregates could we use? What kind of fibers? And I feel really passionate about saying, see what is available to you locally and test. Because sure, we know that certain things work well, like, for example, straw works quite well, or plaster sand works well, but depending on where you are, those things might be hard to come by, or like they might be expensive, they might be not locally like grown in your bioregion, and so forth. So really start looking around what kind of aggregates are available in your bioregion, so that you can cut down on transport costs and embodied energy of that, and really truly create something that is local to you. So often sands are quite useful in mixes. In some places, sands are very abundant. In other places, sands are kind of scarce or not well graded. By well graded, I mean there's a good particle size distribution in the sand. You can ask, like, could we use a beach sand? I'm a little bit reluctant using beach sands, because beach sands have rounded corners and there's salt present. So I know it does get used in places, but I'm a little bit hesitant to say, yes, go ahead and do that. In some places you find more, there is your fine gravels, or there is things like crushed rock. Sometimes that's a waste product from certain crushing operations. Really interesting also, in some places there is deposits of pumice. And then you would also be looking for your more biomaterials, like your, for example, straw or hemp or cellulose, wood chip, stuff like that. So not every biomaterial is useful. For example, things like that decay very fast, like pea straw, I would stay away from that. And some biomaterials don't have the right shape. So they're too coarse, or they don't like hold water really well. So if you're steering away from, you know, the traditional, your straw, your wood fibers and so forth, and want to really experiment with very local materials, I would say just make test mixes and see how they perform. And with all these things, with all the aggregates and fibers, the particle size and the particle shape does matter. So you will find that, for example, with your wood, a sawdust might not perform as well as a wood shaving, so from planing. So really encouraging you to pay attention to what is available locally and in what quality, in what sizes, and aim for something that really can get covered well with clay, and also different particle sizes so that they all lock in with each other nicely. So yeah, and really when you're developing your recipes, start with that end in mind. So start, if you're doing a plaster, start by mixing different ratios and testing plaster samples. And to do that, you will start the way we did before. You will start by soaking the clay and really working the clay into something that has nice cohesion and is good to use. You know, it doesn't have little clay lumps in it anymore. It is really well worked. Sometimes a little bit on the watery side, or like on the not pourable, but it can be more liquid than the plasticine state I just showed you. And then you start mixing in your aggregate. So for example, you can mix in well-graded sand, or you also put in fibers and so forth, and you start making a mix that satisfies sort of the texture, like the workability and so forth. And then you make the test samples at the thickness that you're actually looking at. So for a plaster, you would be looking at maybe 10 millimeters. If you're making a brick, you just cast a proper brick to see what happens, because different thicknesses of material will matter. And you start methodically adjusting your recipes. So you will test samples with different ratios, and then when these dry out, you can observe what happens. So you would observe cracking patterns, dusting, weakness, and so forth. And you can fine-tune your recipe. So this is just a visual impression of what I mean with this. So, you know, typically if you would just be using a high clay content subsoil as is, you would end up with a lot of cracking. It's not actually that useful for most applications. It looks cool in some instances, but you have a lot of cracking and sort of just cracks and falls off. When you start adding more sand to this mix, you will gradually get rid of the cracks, but you might end up with something that is quite sandy, that is shading. So you need to find that sweet spot between shrinkage and then surface hardness, because when you get that really right, if you have enough clay in your mix, not too much so that it cracks too much, but not like enough, you will end up with something that is really nice and strong and doesn't dust so much. And often adding fibers really helps. So again, you can test, you can do lots of different combinations. You can use just fibers in your mix, or you can combine fibers, aggregates like sands and so forth, mineral aggregates and fibers, and just find that sweet spot and document ideally what you've done, because it is quite easy to do test samples that look quite good, and then scaling that is the next step. So this is how you develop the recipe. It is trial and error, and really encouraging you to try different types of aggregates, and you would be surprised, even your sands. So some sands have more fines in them, and some sands are rounder, and they will give you a different result. So actually, just circling back to that jar test, when using sands, I find it really useful to do a jar test on your sand, because you're not only looking at particle sizes of your sand, and doing a jar test where you put your sand sample into a jar, shake it up with water, and then let it settle out will give you an indication of how much many fines you're dealing with. And that is quite useful to, at least just having a feeling for it. Because if you're using a sand that has a lot of fines, you will end up with cracking. So it's basically like introducing, it's not like silt, but it goes towards the silt because you're like working with a lot of fines. So doing a jar test on your sand is interesting. And here I'm just showing you a couple of options, just circling back to that activation of cohesion. So really important to mix properly. And that becomes even more important when you're then scaling. So when you're making a small sample, you're just working with your hands, and it's quite easy to do a good job. You would maybe be kneading it for 10 minutes or something. Depending on your soil, it's less than that. But it's not a big effort to put some decent amount of work into your sample. But when you're scaling, the mixing actually becomes quite a big part of the whole overall job. So really important to have a strategy in place to streamline that. And that can be, having a few people around that are stomping. For smaller projects, that works well. Or you can have a handheld rotary hoe or a pedal mixer. Or if you're then going to a bigger operation, I would suggest, utilizing machinery. We have a rotary hoe on the back of a tractor. And depending on where you are, these kind of machinery, agricultural machinery is available. So you will be able to find someone that can just come and support you making a big amount of mix. You don't have to have a tractor yourself. But again, that's part of that bigger picture is what is available for me locally, what are the logistics of me doing these things at what scale, and seeing if there is resources available locally in terms of support mixing is very advisable in my opinion. Because the beautiful thing about clay is that once it's activated, it only dries out. So you can make a whole heap of mix ahead of time. You just need to keep it covered so that the water doesn't evaporate and it doesn't set. It doesn't have a chemical set. So it is not like preparing concrete where you have a chemical set and you have to use a mix in a certain amount of time. You can just make up a whole heap of mix and then use that mix as you go along. And the next step, so I'm taking you, from soil sampling recipes, making test samples, and then you would decide whether a test sample is useful or not, and if it needs to be adjusted. And for applications like your earthen plasters, the test is easy. You apply it and you see, is it hard? Is it dusty? Do I like it? Do I like the color? Do I like the texture? So for those kind of applications, it's not a big deal to decide whether the sample is good. It becomes more of an issue when you're preparing materials that have to fulfill certain strength requirements that are used, for example, in load-bearing walls. And that's where the New Zealand Earth Building Standards come in. So very good set of standards applicable worldwide, has in high regard worldwide, and it's just been revised too in 2020. So very good to in regards to supporting owner builders to test themselves. Or if you're a producer of earth building materials, it would be a first step to test yourself, and then you could give these standards, or like the standard procedures, to a testing lab so that they can certify you independently. And the tests are really developed in a very user-friendly way. So they are not complicated. Some of them can be done in the field, or very simple testing setup. And I'm just showing you this at the end. Like it is, I have talked about these standards in a previous live, but it has this one standard just looks at materials and workmanship. The other standard looks at design. And the one we're talking about here is 4298. So it has a table 2.1, which shows different earth building techniques and then specifies which kind of tests should be done. And then further in the standard, you have the in-depth description of these tests, how to set it up, you know, what has to happen, what is a pass, what is a fail, and so forth. And the requirements, you know, how many of these tests you have to do, how often, if you want to get a consent in New Zealand. But even for overseas people, it is a very simple way of getting really good confidence that a building material is strong enough. In actual fact, like after the Christchurch earthquake, the Kaikoura earthquake, so a lot of earthquakes happened in the last decade, and all buildings, earth buildings that have been built to these standards have done really well. And there's been some learnings from older buildings that were not designed to standards, and the revised standard has just been tweaked a little bit. So just putting the link here, I will also drop this into the comments below. It's a very good document to look at. The older version is available for free. The new version is paid, and it is very good to support these standards by purchasing them. And yeah, both standards, the design standard and the materials and workmanship standards, are very user-friendly in terms of, you know, being understandable, and like it's basically follow along and you can create a safe and durable earth building. So this brings me to the end of today's live, and I'm just going to have a quick look at if there were any questions. So if you're here live, I'm happy to take questions, and if you're watching the replay, you can just pop them into the comments below and I'll scan through them, or you can DM me and I'm happy to answer those questions. And yeah, just having a look, there's nothing here now, so I will just wrap it up and wish everyone Happy New Year and wonderful start to 2022. And I will be back next Wednesday with the next live, and I'm really enjoying this. So yes, thank you for being here. Thank you for watching. And if you're watching the replay, I hope you enjoy. Bye.